Hello everyone, today we're going to talk about reactions of acid chloride and acid anhydrides. Week 7. Okay, so first we'll look at an acid chloride reaction and its mechanism. So let's say we had this. And we want to react it with water. We get, oh my gosh, this with HCl as our byproduct. Now we can look at the mechanism for it. So we start, with our ring. And then let's react it with water. So the oxygen lone pairs are going to attack this carbon right here. So this double bond's gonna break. So the new structure is going to look like this. So that's the water that just attached. We still have our Cl group, our oxygen there, and then with all their lone pairs, they're gonna go back down to get you a double bond, and then this is gonna kick out the chloride. Which will give you this ring. So we still have the water, we still have this oxygen here. And if we react it with water again, the oxygen lone pair is going to attack this hydrogen here, and then this bond is going to go back to the oxygen. In which we'll get that. So in the beginning, I just forgot to write H3O plus. So that's the mechanism and reaction of acid chloride. And now if we look at an anhydride reaction mechanism, we could see some difference. Okay, so let's say we start with this, and we react it with water and an H plus, we get this. So if you look, we get the exact same thing, except this one just has a ring attached to it. Okay, so now let's just look at the mechanism for it. So we have this. React that with the H plus. this oxygen's lone pairs are going to attack that hydrogen, which is going to give us this, and it's going to be positive because it has too many bonds on it. And then when we react that with water, these lone pairs are going to attack this carbon right here, and then one of these double bonds are going to go back to the oxygen. And then we're going to get this. We have an H here. We have the water right there. And then if we were to react it with water again, these lone pairs are going to attack this hydrogen, and so then this bond goes back to that oxygen, which would give us this. And then once we rearrange, so this bond is going to go to here, and then it's going to kick this out, giving us this group here. Positive, so that's this right here, because remember we brought that down to give us the double bond. And we also have that one, so that one's this part that we kicked off. And so this oxygen's lone pairs are going to attack this hydrogen here, and then this bond is going to go back to that oxygen to give us two equivalents of our product. So really we could put two equivalents here. Okay, and now we're going to look at a reaction wheel. Yeah. Okay, so let's say we started with this, and then we reacted it with an OH group attached to some R group and pyridine. We'd get, this is R prime actually. That so the Cl is just gonna be roaming around. As you can see, this H left, and then this group attached to that carbon there, and then that's what made the chlorine leave. Okay, and then what if we were to react it with an excess of NH3? We'd get this R group there, but instead of the Cl we'll have NH2, and roaming around is NH4 and a chlorine somewhere. Let's keep going. So if excess R prime NH3, what would we get? Basically the same thing as this one, but this time the N is attached to the R prime group and just one hydrogen. And then for the byproducts. We have an RNH3, and then this N is positive. We just have a chlorine somewhere. Yep, because it's excess. So, you're going to have more than just one R group. And then if we reacted that excess, let's see, an R prime with a nitrogen, another R prime hydrogen, you can get R, your oxygen is still there. Your N, instead of being attached to one hydrogen, you're going to be attached to none. So the nitrogen is attached to both R1 groups. And then byproducts, we have that, two of those, NH2, it's a positive, and the Cl minus, as always. And then all these in yellow are nitrogen nucleophiles. Okay, so now let's look at carbon nucleophiles. So if we reacted this with an R prime prime magnesium bromide, if I had space, for our first set and the second set we use H3O plus, we'd get an OH group. We still have an R prime prime, and another R group there. We were to react this with R prime prime, but two of those, calcium and lithium, for the first step, and then for the second step, H3O plus, we'd get our prime prime group, an R group, and our regular oxygen. I'm not gonna have space, but it's okay. And if we reacted that with water and some pyridine, we get this group. Well, now let's say we wanted to go backwards. Go lighter. Go backwards from this to this. We would use SOCl2. And those are all carbon nucleophiles. Okay, now we can look at oxygen nucleophiles that I did start here and I completely forgot. So if we were to react that with water, we would get we have an OH group and our oxygen is still there. Or if we used an R prime prime with an oxygen there, and then sodium, we'd get prime prime in our oxygens. So all three of these are oxygen nucleophiles. Okay, And then if we were to look at a smaller wheel, if we started with the exact same thing, but with different reagents this time. For example, if we used lithium, aluminum, H4, we just get an R group and OH. This is a primary alcohol. Or if we used, for the first is dibol H and then H2O. We get the R group and H instead. And our oxygen here. Okay, what about this with an R prime NH2, two equivalents? Not enough room. We get an R group, or N, with an H, or R prime, with salt. And we could do one more, I guess. In R prime, with two of those with CuLi, we'd get an R prime, and then our oxygen. That is the end of this video, and thank you.